Welcome to solverfy.
We want to prove that there is a positive integer that equals the sum of the positive integers and not exceeding it. We want to discuss about the proof being constructive or non-constructive. So we're going to do the following. Let's say we have n be a positive integer, that is a natural number, such that it equals n equals the sum of the positive integers not exceeding it. That is, the positive integers less than or equal to n. So the sum of 1 plus 2 plus up to n. These are the positive integers not exceeding n. The first positive integer exceeding n is n plus 1. So those who do not exceed n are 1, 2, up to n. Because indeed n equals n, but not exceeded, it does not exceed n. So that's the thing, that's the equation we got to solve. That is, for a positive integer n, we got to solve this equation here. And the idea is that we know a formula for the sum of the first n natural numbers, or positive integers. And that sum, the Gauss formula, let's say, is equal to n multiplied by n plus 1 divided by 2. That is, the sum of 1, 2, up to n is equal to n times n plus 1 divided by 2. So that's the equation we have to solve for n to find the answer. So 2 times n multiplied by 2, both sides of the equation, is equal to n times n plus 1. That is, 2n is equal to n squared plus n. So we put 2n to the right, and we get n squared plus n minus 2n, get to be 0. And then this is n squared minus n equals 0. And we can factor out n. We get n times n minus 1 equals 0. So if we have the product of two positive integer numbers equal to 0, that means that either n is 0 or n minus 1 is 0, or both. In this case, there can be only one true statement because we are talking about the same number n. That means that n is 0 or n is 1 by adding 1 both sides of the last equation, n minus 1 equals 0. So n is 0 or is 1, but n is positive, a positive integer. That is, n is positive, so it cannot be 0. So since n is positive, and the only other option is n equal 1, we conclude that n is equal 1. And that's the only number having the property, that is, the only positive integer such that it equals the sum of the positive integers not exceeding it is 1. And we know that because we started with a general positive integer n, did the calculations, and we conclude the only possibility is that n equal 1, no other. So we verify that 1 equals the positive integers, the sum of the positive integers not exceeding 1, and that the only positive integer not exceeding 1 is 1. So the sum reduces to number 1. There are no more positive integers to add up. So that's it. And as you can see, because we started with the general positive integer to be found, we use this formula for the sum of the first n natural numbers and did some algebra to find the number n. this is a constructive proof. Non-constructive proof. We are not constructing the solution. We are just proving in general what is the solution. So that's it. So n equal 1, and that completes the exercise.